Hi guys, welcome to today's video. We're going to be doing the 2019 Paper 1 Question 8 involving trigonometric functions, which have appeared a lot recently on Paper 1. So let's get into it.
Okay, so here's our question. We're given this function RT that represents the weekly revenue produced by companies selling air conditioning units. We're told that the revenue is given in euro, and T is the number of weeks measured from the beginning of July, and pi over 26 times T is in radians. Right, so part A asks us to find the approximate revenue produced 20 weeks after the beginning of July and to give our answer correct to the nearest euro. So because T is measured in weeks and we're given the number 20, we're just going to plug in 20 for T and see what we get. So when we sub in 20 for T, we're going to get 22,500 cos 20 pi over 26 plus 37,500. And at this point, it's easy to just plug this into the calculator rather than try and simplify this anymore. And one really important thing is to make sure that you change your angle unit to radians. So however that works in your calculator, just make sure you do that. And the answer you're going to get is 20,658.50. But of course, we're asked to round this off the nearest euro. So we have 20,659 euro. So that's our approximate revenue produced 20 weeks after the beginning of July. And for getting that out, you're going to get 10 marks. For part B, we've got to find two values, so very important, of the time T within the first 52 weeks when the revenue is approximately 26,250. First of all, we're just going to rewrite RT and then let this equal to the amount that we want it to be. So that's this equation here with 26,250 on the right hand side. And basically what we're going to do now is try and get T on its own, which will give us a value for at the time, which is what we're looking for. And to also make sure that we do two values, but we'll get to that. So first of all, just taking away 37,500 from both sides, we'll get this. And now we're just going to divide across by 22,500 to simplify it a bit further. And we're going to get just minus a half on the right hand side, which definitely looks right. And it's quite a nice simple cos problem now. So we can say that pi t over 26 is equal to the cos inverse of minus a half. So we're just going to go shift cos minus 0.5. Once again, making sure that your calculator is in radians. We're going to get 2/3 pi. So there we have one equation. But if we can recall, the question asks us to find two values. So basically what's happening here is the calculator will give us the value between 0 and pi. And we've got to find the other value that lies between pi and 2 pi, because 2 pi is a full revolution of the unit circle. So basically, in order to find the other value that we're looking for, we're just going to take 2 pi over 3 away from 2 pi, and that's equal to 4 pi over 3. And we do this because, and we are doing this because the sine, cos, or tan of any angle is equal to the sine, cos, or tan of that angle taken away from 360 or 2 pi, depending on which unit you're using. So that's kind of a rule you need to learn that generally will help you with these questions. You could just have done this to trial and error as well, so just kind of plugging in different values to see what would give you minus a half when you find the cos of it, but this way is probably the best way to do it. But anyways, we have two values now, and we're just going to let those equal to what we have up here. So now we have these two equations over here on the left. So just multiplying across in each case by 26 and dividing across by pi, you'll find that your first value of T is equal to 52 over 3, and your second value of T is equal to 104 over 3. So those are our two cases. We're just going to put them in a little box so that they're obvious. So that's part B. Nothing too difficult there, just to recognize that I need two values, and how to actually find those two values is the only tricky thing. But for getting out part B, you're going to get 10 marks.
So this question is just going to involve some straightforward use of the chain rule. So in order to find the chain rule, we're just going to go over our log tables. So this question is just going to involve some straightforward use of the chain rule. And the chain rule can be found in our log tables. And the chain rule can be found in our log tables. So we have that just here. We're just going to write that out. And we know we have to use this because we have a cos function, but with t inside the bracket. So this is sort of like a function within a function, and that means you need to use the chain rule. Now, first of all, we're just going to figure out what the derivative of cos is. So that's just minus sine here. And that's the kind of thing you will know just after a while, but it's in the log tables if you need to have a look. So given all of that, we can now find r dash t. So our 22,500 is just going to stay the same. We're going to have the minus sign of whatever we had the cos of in the question. So in this case, pi over 26 times t. And also the derivative of whatever was inside the brackets. So the derivative of t times pi over 26 is just going to be pi over 26, because we had t to the power of 1, that's just going to disappear. So that's r dash t. And if you wanted to tidy that up a little bit, you can rewrite it as minus 11,250 pi over 13 times the sine of pi t over 26. So for finding the derivative and completing part C, you're going to get, so for finding the derivative and completing part C, you're going to get 5 marks. So for finding the derivative and completing part C, you're going to get 5 marks. Okay, so for part D, we've got to use calculus to show that the revenue is increasing 30 weeks after the beginning of July. So basically to do this, we're just going to use our rate of increase, r dash t, that we found here above. So we're going to rewrite that. So given r dash t, all we need to do now is plug in the value 30 for t and see whether or not this is positive or negative. And if it's positive, it's going to be increasing, and if it's negative, it would be decreasing. So here we have r dash 30, and now in order to find whether or not this whole thing is positive or negative, we're just going to consider that this part of the expression is negative. So therefore, if this part is negative as well, the overall expression is going to be positive because we have two negatives multiplied together. So we're just going to find sine 30 pi over 26. And the first thing you should be thinking here is to ensure that your calculator is in radians, or else you're just going to get the completely wrong answer. So we're just going to change our angular unit to radians. Generally to do this, you're just going to press shift and setup, but it kind of works differently on each calculator. But we know that sine 30 pi over 26 in radians is going to equal to minus 0.464. So therefore both minus 11,250 pi over 13 and sine 30 pi over 26 are negative, which means that our overall r dash 30 is going to be positive. And the reason I've done it this way is because sometimes you're going to have unknowns left in your derivative. Although it's rare, sometimes you can have to determine whether or not something's positive or negative without given all the information. So you can do it this way. But if you plug it all into the calculator, you're going to get 402.164 pi, which is of course greater than 0. And this means that our revenue is in fact increasing, and we've shown this. And for getting out part D and showing that r dash 30 is positive, you're going to get 10 marks. So part E, the final part of this question, asks us to find a value for the time t within the first 52 weeks when the revenue is at a minimum, and use r double dash t to verify the answer. Okay, so we're just going to break this up into two parts. The first thing we're going to do is find the points at which the revenue isn't increasing or decreasing. So this will provide us with a minimum and a maximum. And anytime you're looking for a minimum and a maximum, you're just going to set r dash t equal to 0. So that's what we're going to do. So there we have r dash t equal to 0. And because this is equal to 0, we can just divide across by all of this fraction here. And it's just going to completely cancel out. So what we actually have is sine pi t over 26 equal to 0. So therefore pi t over 26 is equal to the sine inverse of 0. And we know at this point that 52 weeks is a full revolution of this function. So if you were to plug in 56 for t, you'd end up with sine 2 pi, which would bring you back to where you started if you were to put in sine 0. So this function is modeled so that it repeats after a year. And because of this, we know that there's two values of t that we're interested in that will give us something which, when you plug it in here, is going to be equal to 0. So my favorite way to think about this is just to go to the unit circle, which I've drawn very roughly here. But we know that sine of x is equal to 0 both here and over here, because in the unit circle we treat sine x as the y coordinate, and similarly cos is equal to 0 in these two places. And so you can sort of use this to figure out when cos or sine is equal to 0, 1 or minus 1, which is very useful. So with that in mind, we know that here we have 0, and half a revolution is going to give us pi. So that will give us two nice equations for pi t over 26. Our first equation is really just t is equal to 0. And our second equation is t is equal to 26. And this makes a lot of sense if you think about 52 weeks being a full revolution. 26 is halfway between that, so it sort of just adds up nicely. So now we just need to determine which one of these is a minimum and which one is a maximum. So they've told us to use r double dash t to do this. So we're going to have to figure that out using differentiation. So here we have r dash t, and we're just going to use the chain rule to differentiate this, which as we know is just here in our log tables. And we also have sine involved, so we know the derivative of any sine x is just going to be cos x. So now we've got our derivatives. We're just going to apply them to find r double dash t. So our fraction on the outside is just going to stay the same because it's a constant. We know the derivative of sine is just cos, and we're going to leave whatever's inside the bracket the same. And now we're just going to find the derivative of whatever was inside the bracket, and we're going to multiply all of the expression by this. So that's just equal to pi over 26 because we're just dropping the t to differentiate that. So if you want to, you can simplify this a little bit, but I think it's easy to just plug in both 0 and 26 and see which one gives us a positive and which one gives us a negative. So the r double dash of 0 is going to be equal to all of this, but we know that this part is negative, and we also know that the cos of 0 is just going to be 1. So therefore, r double dash 0 overall is negative, or it's less than 0, meaning that when t is equal to 0, we're actually at a max. And I know this seems sort of counterintuitive because it's less than 0, and yet it seems to be a maximum value. What it actually means is the slope is becoming less steep in the positive sense as you approach the maximum, so the rate of change of the slope is actually less than 0, but it's probably something you should just learn off because it is kind of hard to go through the thought process every time. So here we have r double dash 26, our other value we need to test. And notice that in here, we have a 26 on top and bottom. We're just going to cancel those out. So basically what we have is some negative number on the outside multiplied by this positive number and also multiplied by the cos of pi. And the cos of pi is equal to -1. I think this is in the log tables and you can also use a calculator, but that means that the expression overall, because we have this negative multiplied by a negative in here, which are both unaffected by this positive, this just means that the expression is going to be overall positive. So this means that we have a minimum here. So we found a value of t for when the revenue is at a minimum in the first 52 weeks. And that value is equal to 26. So that's it for part E. Definitely the hardest part of the question. Although it is definitely worth your while because just for doing part E alone, you're going to get 15 marks, which is a good amount of the 50 going for this entire question. But that's the end of this question, and that's actually it for this video. I hope you enjoyed it. If you did, there's going to be other similar videos in the description, as well as some other helpful resources, and I'll see you next time.